Hey there folks, my name is Dan Goodman and I want to welcome you to another rousing edition of Stormwind Studios succinct, held online, remote training sessions, or shorts as we like to call them. This is the 15th short in the Wireless LAN Essentials series of shorts focusing on some Cisco wireless LAN features. Now, big disclaimer I have to throw in here in the early goings is this may not be as short as we're used to. So buckle in, Buttercup. A lot of these features we've actually mentioned in passing as we were discussing the controllers and the access points. Now it's time to circle back to them and have a more in-depth discussion on each one of them. So let's get to it. The first one we want to cover is management frame protection. Now, when we talk about Ethernet or 802.3 frames, they're going to be modified for use on 802.11 networks. That's because an 802.3 frame includes the sending and receiving MAC address, otherwise known as the source and destination. That source address is used as a return address for reply traffic. The destination address is used for delivery and also so that the recipient can verify it is actually the intended recipient. Now, for local communications in a switched network, the switch merely accepts frames on one port, consults its CAM table for the destination port, and switches the frame out of that port. In reality, the host doesn't really even know that the switch is involved in the communication process whatsoever. Now, when we compare that to 802.11, the access points are active participants in the communication. Every frame goes to the access point, and the access point is ultimately the manager of that basic service set. Wireless networks are also based upon the same MAC addresses, and each radio interface requires its own MAC, even those on the access point. So from the client perspective, the access point's MAC address is the BSS identifier or the BSS ID, and that gets included in every frame sent to the access point. So we have a few different frame types available to us on 802.11 networks. Now, when you break down those frame components themselves, they're basically what you see in these two tables we have listed here. The frame control field is of particular importance to communication in wireless networks. It's a 2-bit type and a 4-bit subtype in the header. There are several different subtypes, but the most commonly used frames are what we see on the table to the right: management, control, and data frames. Now, for the purposes of this discussion, we're only going to talk about the management frames themselves. So you see in that first column underneath the management header, we have all sorts of different management frames. They're primarily used to advertise a basic service set, its capabilities, as well as manage clients. Technically, there are 14 different management frame subtypes, but the most common ones we're going to talk about here. The first one is the beacon. This particular frame is broadcasted to advertise the basic service set, the allowed data rates, and the optional security set identifier, as well as the vendor information. By default, it's sent to all devices in the basic service area about 10 times per second. And there's going to be different beacon frames for each wireless LAN. The probe request and the probe response frames. The request frames go from the clients to the access points within range to inquire about their basic service set. This is known as active scanning. Now, the response frames come from the access points, essentially containing the beacon information we just discussed a second ago. There's also authentication and deauthentication frames. The association process between a client and an access point usually begins with some sort of authentication request from the client. Hey, I want to connect. What do I have to do to connect to this access point? Now, the access points can either support open system authentication or shared key authentication. Open means there's association that occurs almost immediately without any other sort of additional authentication. Shared is where the client must exchange the security key that matches that of the access point. Now, assuming, of course, the client successfully authenticates itself, the access point will generate an authentication response frame when successful. Deauthentication frames are used when the client wants to leave the authenticated state, but access points can also force clients out of authentication with their own deauthentication. Now, there are other frame types known as association, disassociation, and reassociation. Once authenticated, the clients will send an association request frame to join that basic service set. The access point will respond with an association response frame if the client supports the parameters of the basic service set. To gracefully leave a basic service set, a disassociation frame comes from the access point down to the client. Now, the client can also say, hey, I no longer want to be associated. So a lot of these come from either side of the equation. Now, as a client leaves one basic service set while remaining connectivity to the original SSID, this is known as roaming, a reassociation request frame is sent to the new access point, which is also supporting that SSID. That access point will respond on behalf of the SSID with a reassociation response frame. Finally, we have action frames. Now, these are kind of a liquid type situation, if you will. This provides a communication method for an extended management action to be taken. It's kind of earmarked for future amendments to the 802.11. Some of that information has trickled out, but nothing's concrete yet. Just kind of keep in mind that there are things known as action frames. Now, since all of these fall under that management header and all of the information contained within it is considered sensitive information, it's information about the wireless LAN, the clients, they probably would benefit from some form of protection. And that's where management frame protection comes into play. Management frame protection essentially adds a layer of security to these frames to prevent things like spoofing attacks, denial of service, or even man-in-the-middle attacks. So what it actually does for us is kind of described here. When we take a look at it, MFP was originally considered a Cisco proprietary product that was or is a precursor to the 802.11w amendment. Basically works in two functional modes: infrastructure only support, otherwise known as MFP version 1, or client and infrastructure support, known as MFP version 2. Now, with version 1, this provides very quick and accurate spoof detection. However, the clients don't necessarily receive any protection themselves. MFP in this case would rely upon key management to distribute MFP signature keys for frame protection and validation. These keys ultimately calculate a timestamp, a sequence count, and something known as an MIC, or message integrity check. In this particular mode, the access point will validate every management frame it receives from other access points because each frame is cryptographically hashed. If there's a mismatch, it assumes there's an attack. If it's the same, probably, most likely, hopefully, there's not any sort of attack going on. Now with version 2, as the name implies, both the clients and the infrastructure are shielded from spoofed frames. In this particular mode, the clients themselves will encrypt the MFP frames that get sent between themselves and the access points. The access points will also encrypt them whenever they're communicating with other equipment in the infrastructure. Now, the reason I have an asterisk attached to this one, let me say that correctly, is because this particular version is only possible with Cisco compatible extensions version 5 clients. This gives both the access points and the clients the ability to take the preventative action. Basically, the spoofed frames are simply dropped, but you have to remember that CCX is not installable on every particular type of client device. So that's why most deployments end up using version 1 more so than anything. Now, the next Cisco wireless LAN feature to discuss is IPv6. I definitely don't want to turn this into an IPv6 101 discussion with the hexadecimal and converting between the two. That's better left for our other courses. Instead, we want to focus on it from a Cisco wireless LAN perspective. Pre-software release 7.2, which came out in 2012, the IPv6 clients were essentially supported by bridging functionality. Those IPv6 packets could flow very inefficiently through a wireless LAN. It was a good band-aid at the time, but we needed a long-term solution. So between versions 7.2 and 8.0, starting around 2014, the controller would intercept the IPv6 traffic. This gives the controller the ability to learn and track this particular traffic. This essentially brought IPv6 support on par with IPv4 support. Intercepting the traffic increased efficiency by controlling the amount of traffic. Rather than the way they used to do it via a bridge, essentially, they were essentially just passing it along, even if it was the same packet over and over and over and over again. Now, by learning about it, we get the ability to filter what we need to filter and send out what we actually need to send out. So when we take a deeper look at that, currently 8.0 handles IPv6 as efficiently as possible. The controller is accessible via its wired and wireless IPv4 and IPv6 management interface. So that was an additional feature that was added to this. So that means we can use HTTP, HTTPS, secure shell, variety of methods to access that interface. We could also have TFTP access via IPv4 or IPv6. NTP servers could either use IPv4 or IPv6, and we had built-in ping support with both IPv4 and IPv6. Kind of continuing on this discussion here real quick, we briefly need to discuss the client types and its impact on mobility roaming, as well as the other types of IPv6 addressing. Beginning with the client types, the most advanced clients are considered IPv6 native since they only use IPv6. IPv4 clients are considered, take a guess, non-IPv6. Finally, there are dual stack clients that are capable of supporting IPv4 and IPv6. Why is that information important? Well, based upon the client type, there are different pieces of information that determines how roaming occurs. With those IPv4 only clients, the subnet determines how and when roaming occurs. With IPv6 only, the VLAN determines how and when roaming occurs. For those dual stack clients, it basically adds the IPv4 subnet for backwards compatibility. Now, IPv6 also has various types of addresses that affect how the controller learns about that client. There's going to be the stateless address auto configuration, some people say SLAC, and static. This is essentially where the controller learns about the client once it starts sending the traffic. Of course, if we're using DHCP version 6, the controller is able to pick up that address from those DHCP version 6 packets. The next Cisco wireless LAN feature on our to-do list is known as VideoStream. Now you can take a look at all these great, grand, wonderful benefits of how it's going to make your hair shinier and your teeth whiter and all those sorts of things. But if you had to summarize it in a nutshell, it's designed to improve services for bandwidth-intensive, high-impact video streaming. Now, it's supported on all controllers and pretty much every newer model access point, but it does rely upon a couple of things to do what it does best. Basically, that boils down to multicast delivery method. This removes the need to broadcast multicast packets to all wireless LANs on an access point. Instead, we rely upon a CapWAP multicast group to be configured for the delivery of those multicast packets. Stream prioritization gives the user the ability to configure media streams with different priorities based upon importance. This basically is kind of like individualized quality of service, rather than a wireless LAN wide quality of service implementation. It's a lot more customizable in that regard. We also have the Resource Reservation Control, or RRC. This kicks in during network congestion. This will limit and prevent new video streams to protect the clients that are already in a video session. Kind of a first in, first out, if you will. Now, the remaining system-wide features are listed in the table, but I've done my best to describe the big three. Basically, it brings wired video quality to wireless networks. So if you need to pause the video to read these features in the table, I'll give you 2 seconds to do so. 1 Mississippi, 2 Mississippi. Moving on to Bonjour Gateway. Now, Bonjour is an Apple service discovery protocol that locates various resources on the LAN, printers, servers, and other services. As the name implies, it's designed specifically for Apple devices. However, Cisco has implemented their own version. And that's because Apple's version of Bonjour was designed for home use and not enterprise use. One of the other things to kind of include here is that multicast DNS, or MDNS, is used to allow clients to access available corporate resources from their devices, providing a smoother user experience without compromising security measures. So if you're wondering how this all fits into the diagrams that we've got here, focus on this one in the upper left first and foremost. Let's just say that we have a guest that arrives and they need to print something so that they have to access our print resources. And maybe they also want to present something from their iPad. If you take a look at the wireless LAN that guest is connected to, they are currently on the guest subnet, while the printer and those other resources are located on the corporate network. Now, Cisco's Bonjour Gateway is going to be as simple as 1, 2, 3, 4 to make this happen. And I counted 5 there on purpose because it's not that simple. It sounds that simple, but it's not really that simple. The resource, the printer in this case, is on one VLAN, and it advertises its presence. The clients on the resources VLAN will receive that MDNS. The clients in the other VLANs will receive a reflected MDNS. The controller will then note the resource's availability within its own cache. Now, if and when a new client in a third VLAN queries for a resource via a MDNS query, the controller will respond with its cached MDNS showing the resource that's available in the other VLAN. Essentially, the resource advertises itself, the controller stores that information and says, hey, if anybody needs it, I've got that information. That was actually like 1, 2, 5, 7, 10 on some. It was kind of my poor attempt to simplify. Basically, if we boiled it down to those 4 steps, the controller with the Bonjour Gateway listens for services from the Bonjour advertisements, and it's essentially broken down in the diagram behind me. Number 2 is when the results themselves are going to be cached on the controller. Number 3 is when the controller listens for those client service queries. Step 4 is when the controller responds accordingly. So that was 4 steps. Recently, Cisco enabled the access points to serve as MDNS access points. This means that the access point will snoop all of the available wired services and send that information to the controller for caching. Basically, we've got more devices listening for the resources that we would want to share with these folks connecting via Cisco Bonjour. Now, since most of us still care about security, rest assured that Bonjour gives the ability to restrict services based upon profiles. So we can use a combination of wireless LAN, VLAN, location, service, group, user, role, devices, services to kind of rack and stack. These entities have access, these entities do not have access. Additionally, Bonjour policies provide a quick and easy mechanism to select the allowed services. It integrates with 802.1x, AAA, and ISE to apply a profile and a policy to a particular user. The next Cisco wireless LAN feature is application visibility and control. This is essentially application-aware control on a wireless LAN that is able to perform deep packet analysis, basically layer 4 on up, to view, control, and troubleshoot end-user application experience. Now, this is based upon network-based application recognition, or NBAR, found on wired networks. It enhances manageability and productivity. The controller actually has the ability to classify over 1,000 applications. We also get real-time monitoring of applications via the controller interface that provides a true end-to-end solution. The AVC protocol packs allow the devices to update their MBAR protocols without replacing the Cisco software. That basically means it's easy to load, easy to upgrade and downgrade, and provides only the required set of protocols. Now, this particular feature is supported on the 2500, the 5500, the 7500, the 8500, the WISM2 on both local and flex modes. The next wireless LAN feature, we're going to call it guest access. It's technically what Cisco calls it. Whenever we find ourselves providing complimentary access to a wireless LAN for guests, most administrators will place their access point in the DMZ, because the DMZ will essentially limit when, where, and how the guests access the wireless LAN. But this also leaves much to be desired in terms of scalability. What if this was an access point for an amusement park? You're probably going to have a lot of guests connecting to it. Guest access allows guests to access the wireless LAN in more location, hence the name guest access. Now, instead of placing an access point in the DMZ, we place a controller in the DMZ that is dedicated to nothing but guest traffic. This controller thereby becomes the guest anchor controller. Now, even though it's considered the guest anchor controller, guests have the ability to connect to any controller, but all of their traffic will get directed back to the guest anchor controller. So it essentially creates, I hate to use the term tunnel, but that's essentially what it does for us. So in the diagram, we actually leverage the CAPWAP tunnels to provide guest access without compromising security. Now, for the record, controllers have the ability to establish 71 CAPWAP tunnels at any point in time. Now, this provides us a much more robust and scalable solution for guest access. One thing to kind of throw in there, the 2500 series can only establish 15 simultaneous tunnels. Basically, if you have a large need for more tunnels, you need more guest controllers, and you need bigger and beefier guest controllers. The clients can connect to any controller, and their traffic gets isolated from the internal traffic. Clients can connect to this guest wireless LAN since it is statically mapped to that guest controller or those guest controllers. Now, you can also leverage prime infrastructure in this scenario to create guest accounts. In its absence, we can create a lobby ambassador account on the guest controller, kind of giving us the same features as a guest account. Now, guest authentication itself will boil down to 3 steps. We can rely upon the local database for username and password combinations. If no credentials are found locally, the wireless LAN settings will be checked against an external radius server. If no radius server is found on the wireless LAN, the controller is checked for a global radius server configuration. Now, in the event those guest credentials don't match any of those 3, authentication ultimately fails, which probably means we don't want that guest to connect anyways. The next feature we have to discuss is going to be location services. Now, we discussed in an earlier short how location services are provided via the mobility services engine that's primarily used to capture and consolidate information about the RF spectrum, sources of RF interference, users, and devices. This also enables a set of near real-time location services that all ties back into locating the clients, the rogue access points, the rogue clients, the RFID tags, etc., etc. Now, MSE does what it does via signal strength triangulation, fast locate, and presence. The signal strength triangulation triangulates the device by relying upon relative signal strength. The access point will report this information to the controller. The controller will then aggregate that information before forwarding it to the mobility services engine. The mobility services engine will then apply positioning algorithms to eventually display devices on a map in prime infrastructure. We also have fast locate, which relies upon the wireless security module in the access point to add packet information to relative signal strength. The controller once again aggregates the information and will forward it to the MSE. Now, this will add a more accurate device location ability, but it does require that wireless service module we've discussed in earlier shorts. Finally, we have presence. Presence is used to gauge the nearest access point to the device to determine location. This requires fewer access points, but if you think about it, it's less accurate than the other location methods we just discussed. However, it is only available via CMX Analytics or an integrated third-party application. Now, we've mentioned CMX in a few different shorts. We're going to throw that into our wireless LAN features discussion. That was previously mentioned in the network services as well as our Cisco licensing shorts. Now we kind of want to take a deeper look at them in this particular short. So CMX consists of mobile application services, for example, guest access, device-based services, browser-based services, location-based apps, and the other items listed here at the top of this particular graphic. Now, it's all supported by Cisco as well as their ecosystem partner apps and services. That middleware layer is optional and includes the Enterprise Mobility Services Platform, or EMSP. Mobile Network Services focuses on presence, service discovery, security, and APIs. The network element layer delivers visibility, control, optimization, and security. Now, recall from an earlier short, we mentioned that CMX is enabled by the CMX license on Cisco MSE. There are several applications with the CMX license. For example, CMX Connect provides venue-specific information based upon mobile guest access. CMX for Facebook Wi-Fi is guest access via Facebook while also allowing sharing of the venue visit. CMX Location Analytics takes a series of data points and extracts value from them. Finally, the CMX SDK offers customers the ability to write their own third-party code. The SDK would onboard the user to the Wi-Fi and launches that particular venue's application. Kind of just focusing on these connected mobile experiences one more time here. And then we'll close out by discussing the wireless intrusion prevention system. Now, we also discussed the wireless intrusion prevention system during our Cisco Wireless LAN AP mode short, but it's also pertinent to the discussion here because it used to be part of the CMX solution, but it's no longer the case because now it's an additional service running on the physical MSE platform. Now, wireless specific attack techniques are detected by RF airwave scanning. This is integrated into the Cisco Unified Wireless Network to report on malicious attacks, security vulnerabilities, and sources of persistent performance disruption. We essentially leverage existing access points, controllers, the MSE, and prime infrastructure deployments. We get proactive threat prevention that removes security offenders from the network, assist to diffuse network attacks, protect against data theft, and prevent rogue access points. To kind of summarize the main features and benefits, we get rogue detection, classification, and mitigation, over-the-air attack detection, security vulnerability monitoring, performance monitoring and auto optimization, and finally management, monitoring, and reporting. Now, the adaptive wireless intrusion prevention software licenses are based upon the number of monitoring devices, and that's essentially what the asterisk in the graphic is for. There's monitor mode, which is intended for full-time monitoring access points, up to 5,000 access points. The enhanced local mode is intended for local mode or data serving access points. Once again, has the ability to track up to 5,000 enhanced local mode access points. And then the virtual appliances range from 2,000 access points to the low end, 5,000 access points for standard, and 10,000 access points at the high end. So that is all that we have here for this Stormwind Studios short on wireless LAN essentials. Please make sure that you subscribe to our channel so that you are notified of these shorts shortly after they become available. Take care.